All right, this is lesson 3.3, properties of logarithms. We're going to apply properties of logarithms and apply the change the base formula. So the first thing you need to know is that with our properties of logarithms, that these can actually go both ways. So don't just think you can go one way, you can go back and forth. But if we're multiplying after the log base b, that we can split that up into an addition. Make sure you repeat the log base b in front of each of the terms that that are being multiplied. If you're dividing, what you'll have to do is subtract. And this really follows the rules of exponents. When you multiply, you add. When you divide, you subtract. And a power to a power, you bring out front and you multiply. So we're going to change this and we're going to express these logs in terms of a log 5 and a log 3. And they're common logs because there's no base number on there. So it's a base 10. So I want to split this apart. This is going to be a 5. Well, let's go 25 times 3, and then a 5 times a 5. So this is going to be a 5 squared. So this is log 5 squared times 3. And remember, when we multiply, we need to split it into addition. Make sure to repeat the log, and then a power, we multiply. So 2 log of 5 plus log of 3. Now, log of 5.4, I'm going to actually just change this to a fraction. So it's going to be log of 27 over 5. And 27, I need to see what it's going to be. So 27 is going to be a 3 times a 9, which is 3 times 3. So this gives me log of 3 cubed, because there were 1, 2, 3 of them, over 5. And when we divide, we subtract. So it's numerator minus the denominator. And we take the exponent and we bring it out front. And we're done with that. The next thing we're going to do is we're going to evaluate each logarithm. Now, in order to do that, I need to notice the base numbers. And since the base on here is 2, I need to try to get this 32 down to a 2. So this is going to be a 2 and a 16, a 2 and an 8, a 2 and a 4, and then 2 and 2. So 2 to the 1, 2, 3, 4, 5. 2 to the 5th power. The log base 2, the cube root of 2 to the 5th. Now remember how we change a radical? We can change it to an exponent. So this is 2 to the 5/3. And whatever root we're taking goes in the denominator. Now, I'm going to take this and I'm going to put it out front because powers I can move to the front. Log base 2 of 2, which undo each other, and we're just left with 5/3. Next one. Notice here, it's the natural log and then the base e, which would undo each other, but we can't when we have the exponent on it and a number out front. So I need to go ahead and move this number out front. And so this is going to be a 12 natural log of e minus, and this one needs to come out front as well, 4 natural log of e. And now they're inverses, and they will undo each other and cancel out. And I'm left with 12 minus 4, which is an 8. Now, you may have thought, well, why didn't you go the other way? Why didn't you take this power up? I'm going to show you why. It would have been, don't do this, it's going to be a ln e to the 12th minus ln of e to the 4th, because I bring it up and I multiply. And then I need to combine them, so it's going to be ln e to the 12th, and subtraction is division, e to the 4th. This fraction still has the e in it, so this doesn't work. Now we're going to expand each of these expressions, and so I need to split it all up into all those additions, subtractions, instead of just one term. And so remember, when we are multiplying, we can split those up into additions. So this would be the natural log of 4 plus the natural log of m to the 3rd plus the natural log of n to the 5th. Now I don't want the exponents on it, so I need to bring the exponents into the front. And I'm done. Now the next one has some division going on. So the first thing I'm going to do is I'm going to separate out the division with subtraction. This is a really good problem because you can see there's not multiplication there. So this group right here cannot be split apart any farther. So this group has to stay as it is. Now the next group, I need to be able to take this and turn it into an exponent. So x, the fourth root of x, is equal to x to the 1/4. Because of that, now I can do a lot with this. So I'm going to go minus log of 3 minus log of x to the 1/4. Now I can't take this and put it out front right now because the 1/4 is only on the x, it's not on the 3. Grouped in parentheses then you could, but it's not, so don't do that. So this is log of 2x minus 3 minus log of 3 minus, do you remember where the exponent goes? Right there in front. And you're done. Now let's go the other way and condense it. All right, so we need to take care of any number out front first. I want to take it and put it up here on the x. So log base 4 of x to the 1/2. Again, right here. This needs to go, oh, where's it go? It goes out here on the outside of the parentheses. So minus log base 4 of x minus 2 to the 3rd. And now I have subtraction. So I am going to divide. Now the only thing else I'm going to do is I'm going to take this and turn it back into a square root, because anything to the 1/2 power. That's the square root of x over x minus 2 to the 3rd. Next one, where do you start? Right here with the number in front. Where does it go? It goes up as the exponent. Hopefully you were saying that before I did. How does addition combine? As multiplication. The last thing we're going to talk about is to change the base formula. And so if we're given a base, we can change it to any base we want. And usually you're going to want to change it to either a natural log or a common log, because the log base 10 is the natural log and that's on the calculator. And that's where they usually go. Now sometimes it'll go somewhere else, and logs can show up on your ACT. So it's something good to know. So the base always goes to the bottom. So if I wrote log of 8 of 7, well, it's going to be log over log. The base number goes to the bottom. Base to the bottom. Base to the bottom. And that's how you'd set up your change the base. And then you can put it in your calculator and evaluate it. So we're going to change the base on these. So the log over log, and the base goes to the bottom. And the other number's in the numerator. And then you put it in your calculator. And you get that it is approximately equal to 0.77. Now the next one, log over log, and the base goes to the, that's right, the bottom. And so we type that in our calculator, and we get approximately negative 1.89.